You know, if you look at your phone, your computer, pretty much any piece of tech around you, there are literally billions of tiny components inside, all managing this invisible flow of energy. But what keeps that flow from just becoming total chaos? Well, today we're going to look at one of the most important, most fundamental components in all of electronics, the diode. Think of it as a microscopic traffic cop, and its one simple job is what makes our entire digital world even possible.
So here's our game plan. First, we'll get a handle on the main challenge, which is just controlling electricity. Then, we'll check out the basic building blocks of all circuits and see how they're sorted. That's going to lead us right to the star of the show, the diode, and we'll figure out how it creates a one-way street for current. And finally, we'll bring it all home and see how this little guy shows up in the technology you use every single day.
All right, Section 1, Controlling the Current. You have to imagine raw electricity as something like a flash flood. It's incredibly powerful, but it's completely chaotic. So to do anything useful with it, whether that's lighting up a room or crunching numbers on a processor, we first have to tame it. We've got to turn that flood into a nice, controlled river. And that, right there, is the fundamental challenge of all electronics.
And the solution to that chaos? It's the electric circuit. Now, this isn't just a random wire. It's more like a super detailed, carefully planned highway system for electrons. It gives them a very precise path to follow, guiding the current exactly where it needs to go to get a job done. Without the circuit, electricity is just, well, it's just wasted energy. But with the circuit, it becomes this incredibly powerful and predictable tool.
But here is the number one most important rule. That path has to be a closed loop. The current has to start at its source, flow through all the different parts of the circuit, and make its way all the way back to the beginning. If there's any break in that loop, anywhere at all, the whole system just shuts down. It sounds simple, but this idea is the absolute bedrock of everything we do with electronics. So let's move on to Section 2, a circuit's building blocks. Okay, so if a circuit is our highway system, what are the traffic lights, the roundabouts, and the bridges? Well, every circuit is built from this huge library of tiny, specialized parts we call electronic components, and each one has a very specific job to do.
So what even is a component? The official definition says it's any device that affects electrons, but let's put that in simpler terms. Basically, each part is a specialist. You have some that are like little dams, built to resist the flow of electricity. You've got others that act like reservoirs, storing energy up. And then you have some, like the diode we're getting to, that work as gatekeepers, telling the flow exactly where it can and can't go.
Okay, Section 3, active versus passive. Now, all these components, they really fall into two very different families. The easiest way to think about it is like the difference between a rock sitting in a river and a giant hydroelectric dam. I mean, they both affect the water, right? But one is just passive, it's just there, while the other is actively controlling the flow. And this distinction is absolutely key for understanding where our little diode fits into the picture. This table really breaks it down for us. Over here, you've got your passive components, like resistors and capacitors. They can use or store energy, but they can't really make any decisions. They're sort of the roads and the pipes of the circuit. But then, on the other side, you have the active components. These are the brains of the whole operation. They can amplify a signal, or, and this is the important part, they can control the flow of current. And would you look at that? Right there in the active category is our diode, the traffic cop of the circuit. Which brings us to Section 4, electricity's one-way street. We have finally arrived at our main event. We're going to zoom in now on one of the simplest, but also one of the most essential active components that exists, the diode. This is the big question. This is the whole reason the diode was even invented. I mean, for so many things in electronics, from charging your phone's battery to protecting a super delicate computer chip, you have to be able to guarantee that the current flows from point A to point B and never, ever goes the other way around. So how do you do it? How do you build a perfect one-way street for something you can't even see?
And the answer is the diode. Its design is so elegant, and its whole purpose is singular. It lets current flow through in one direction, no problem. But if that current ever tries to turn around and come back, it slams the door shut. It's an absolute no-entry sign. And this amazing function, turning a two-way path into a one-way street, has a name. It's called rectification.
Honestly, the best way to think about it is as a one-way valve, or maybe like a turnstile at a stadium. You can push your way through in the forward direction, but just try going back. No way. It's a really simple physical analogy for a super important electronic principle.
And if you ever look at a circuit diagram, the diode symbol is basically its own instruction manual. The triangle is an arrow, and it's pointing in the only direction that the current is allowed to go. Current comes in on the flat side, which is called the anode, and it flows out past that vertical line, the cathode. And that line is like a wall. It's a visual cue telling you, nope, you can't come back this way.
So let's get to section 5, the diode in your life. Because this isn't just theory, right? This is the fun part, where we connect this whole one-way street idea to the stuff you actually use every single day. And trust me, you'll be surprised where these things are hiding.
Diodes are really the unsung workhorses of the electronics world. Their biggest job, by far, is converting power. But they're also used as a kind of safety switch, protecting your gadgets if you happen to plug a battery in backwards. And, as we're about to see, a very special kind of diode has completely changed how we light up our world.
So, to really appreciate the diode's biggest job, we need to quickly talk about the two flavors of electricity. The power that comes out of the outlets in your wall is alternating current, or AC. The flow is constantly reversing direction, back and forth, back and forth. But your phone, your laptop, pretty much all modern electronics, they need direct current, or DC. That's a nice, steady, one-way flow, kind of like water coming out of a tap.
So you've got this chaotic back and forth AC from the wall, but your phone needs that steady, smooth DC. How do you make that happen? This is the Diodes Killer app. That little power brick for your phone is basically packed with diodes. As the AC current tries to push back and forth, the diodes act like a series of one-way gates, and they just block the entire reverse half of that flow. So what comes out the other end is a current that only flows forward, which is exactly what your phone's battery needs. That conversion process is rectification.
But wait, there's an even more obvious place you see diodes every day. What do you think LED stands for? Light? Emitting? Diode. It's right there in the name. An LED is just a diode that's made from some special materials, and when current passes through it, as a cool little side effect, it releases that energy as visible light. It's literally a one-way street that glows.
And you can see this right in its circuit symbol. Look, it's the exact same one-way arrow symbol as a normal diode, but it has these two little extra arrows pointing away from it, and those arrows are just indicating that light is being emitted. It's the same fundamental component, just with this brilliant little twist.
So there you have it. From charging the very device you might be watching this on to lighting up your home, the humble diode is a true unsung hero. It's the perfect example of a simple component built on a really simple idea, a one-way street for electricity that quietly makes our entire modern world run. And it really makes you wonder, doesn't it? What other simple ideas like this are out there, hiding in plain sight, running everything?